Hey, good morning, everybody. Pray be to the Lord. We're going to continue with our topics of math. Okay, so we're going to start to make a review about volume. Okay, because the topic is combine volume. Sorry, combined volume of a prisms. Okay, what is the meaning of that? We're going to make calculus as we see here about two figures, okay, and find the volume of all of that figure instead. Okay, so we're going to make a review. We're going to watch a video about what is volume, then we're going to watch a video what is the combination, or how we can combine two figures and start to make the calculation. So please watch the video and please take notes, because it's very important for you to take notes. And the next hour we're going to make exercises. Okay.
Grammarly does more than catch errors. With Grammarly, you can find really good, perfect words that make your writing sharp or explicit. Hi, I'm Rob. Welcome to Math Antics. In this lesson, we're going to learn about another important geometry quantity called volume. Specifically, we're going to learn what volume is and what kind of units we use to measure volume, and how we can calculate the volumes of a few simple geometric shapes. The first thing you need to know is that volume is a quantity that all three-dimensional objects have. But to understand what it means, it will help if we back up just a little and start out with a one-dimensional object, like this line segment. To measure a one-dimensional object, we need a one-dimensional quantity, which we usually call length. The length of this line happens to be exactly 1 centimeter, which is a common unit for measuring length. And in the Math Antics video about area, we saw that if we move or extend this one-dimensional line in a direction perpendicular to it by a distance of 1 centimeter, it forms a two-dimensional object called a square. Two-dimensional objects are measured by the two-dimensional quantity that we call area. Because the original line was 1 centimeter long, and we extended it the distance of 1 centimeter, the amount of area that this square occupies is 1 square centimeter, which is a common unit for measuring area. Okay, now imagine how we take that two-dimensional square and move or extend it in a direction perpendicular to its surface by a distance of 1 centimeter. It forms a three-dimensional object that's called a cube. And to measure a three-dimensional object like this, we use a three-dimensional quantity called volume. Volume tells us how much three-dimensional space, or 3D space, an object occupies. All right, but how much volume does this cube have? Well, since it was made by extending 1 square centimeter, a distance of 1 centimeter in the third dimension, we see that its volume is exactly 1 cubic centimeter, which is a common unit for measuring volume. So square units are used to measure area, and cubic units are used to measure volume. Since square units are made by multiplying two one-dimensional units together, like centimeter times centimeter, we can abbreviate them using the exponent notation, centimeters to the second power, or centimeters squared. And since cubic units are made by multiplying three one-dimensional units together, like centimeter times centimeter times centimeter, we can abbreviate them using exponent notation, centimeters to the third power, or centimeters cubed. And just like there were different sizes of square units, like square inches, square meters, or square miles, there's also different sized cubic units, like cubic inches, cubic meters, or cubic miles. See how area and square units are related to volume and cubic units? And there's another similarity too. To remember how you can use square units to measure the area of any 2D shape, not just squares. Well, you can use cubic units to measure the volume of any 3D shape, not just cubes. To see how that works, take a look at this 2D circle and this 3D object called a sphere, which is like a ball. Just like you can use a bunch of small squares to approximate the area of the circle, you can use a bunch of small cubes to approximate the volume of the sphere. And here's the really cool part. the smaller the squares you use, the closer their combined area will match the area of the circle. And the smaller the cubes you use, the closer their combined volume will match the volume of the sphere. Okay, so volume is a 3D quantity for measuring 3D objects. But since we've also talked a lot about area in this video, I want to point out that 3D objects also have a type of area that you don't want to confuse with volume. You might remember from our previous videos that 2D shapes have both a 2D quantity called area and a 1D quantity called perimeter. Well, in a similar way, 3D objects have both a 3D quantity called volume and a 2D quantity called surface area. Surface area is a lot like it sounds. It's the area of the object's outer surface or shell. Perimeter and surface area are both outer boundaries of geometric shapes. Perimeter is the one-dimensional outer boundary of a two-dimensional shape, and surface area is the two-dimensional outer boundary of a three-dimensional shape. And to help you see the difference between surface area and volume, imagine that you have a perfectly thin box filled with ice. If you unfold the box, you can see the 2D area that surrounds the volume. Well, the volume itself is the amount of 3D space occupied by the ice inside the box. All right, so now that you understand what volume is, and you won't confuse it with surface area, we're going to spend the rest of the video learning how to calculate the volumes of some basic geometric shapes. But before we do that, I want to quickly mention something important about terminology, or the words we use to describe things in math. Most of the time, people agree on what to call things in math, but not always. That's especially true when it comes to the words that we use to describe the dimensions of geometric objects. Take the words length, width, and height, for example. If I have a rectangle, I can name its two dimensions, length and width, like we did in the area video. But I could also name them width and height if I wanted to. The actual names of the dimensions really aren't important, so different teachers might use different names. The important thing is to be flexible and realize that the math concepts are the same, even if different words are used to explain them. For example, the area of a rectangle is always found by multiplying its two side dimensions together, no matter what they're called. Okay, back to calculating volumes. A lot of 3D shapes can be formed by taking a 2D shape and then extending it along the third dimension. For example, if you start with a rectangle and then extend it along the third dimension, you get a 3D shape called a rectangular prism. If you start with a triangle and then extend it along the third dimension, you get a 3D shape called a triangular prism. And if you start with a circle and extend it along the third dimension, you get a 3D shape called a cylinder. From the others, you might have thought that it should be called a circular prism. But technically, prisms are shapes that are formed by extending a polygon. And since a circle is not a polygon, the resulting shape is not called a prism. Okay, so the good news is that there's a general formula for calculating the volume of these types of 3D shapes. All you have to do is find the area of the original 2D shape that got extended, and then multiply that by the length or distance that it was extended. Usually, that original shape is called the base of the object. So, let's start with this rectangular prism and calculate its volume. The base is the original rectangle, and its dimensions are 4 centimeters by 3 centimeters. So to find the area of that base, we need to remember how to calculate the area of a rectangle. To do that, we just multiply the two side dimensions together. 4 centimeters times 3 centimeters gives us 12 centimeters squared as the area. Now, to find the volume, we just need to multiply that area by the length that the base was extended. Our diagram tells us that distance is 10 centimeters. So if we multiply 12 centimeters squared by 10 centimeters, we get 120 centimeters cubed. So this rectangular prism has a volume of 120 cubic centimeters. Okay, let's try to find the volume of the triangular prism now. Again, the first step is to calculate the area of the base of the prism, which is the triangle. The formula for finding the area of a triangle is 1/2 of the triangle's base times its height. Be careful not to confuse the base of the triangle with the base of the prism, which is the triangle itself. Our diagram tells us that the base of the triangle is 10 inches and its height is 8 inches. So 1/2 the base times the height would be 1/2 of 10 times 8. 10 times 8 is 80, and 1/2 of 80 is 40. So the area of the triangle is 40 inches squared. Now what we have to do to find the volume is to multiply that area by the length that it was extended. We're told that the length is 50 inches, so we multiply 40 inches squared by 50 inches, and we get 2,000 inches cubed. That's the volume of this prism. All right, are you ready to try finding the volume of the cylinder now? The cylinder is made by extending a circle, so first we need to calculate the area of that circle. As we learned in a previous video, the area of a circle is found by multiplying pi times its radius squared. The radius of this circle is 2 meters. So if we square that, we get 4 meters squared. Then we multiply by pi, which is approximately 3.14, and we get 12.56 meters squared. Now that we know the area of the circle, to find the volume of the cylinder, we just multiply that area by the length that the circle was extended, which happens to be 10 meters. 10 meters times 12.56 meters squared gives us 125.6 meters cubed. So the volume of the cylinder is 125.6 cubic meters. So, do you see how to find the volume of 3D shapes like these? Shapes that are made by taking a 2D shape and then extending it along a third axis? You just find the area of that shape, and then you multiply it by the length that it was extended, and that gives you the volume. And it works for any 2D shape. It works for trapezoids, or pentagons, or diamonds, or stars, or hearts. Man, now that I know how to accurately calculate volumes, playtime is way more fun. Of course, not all 3D shapes are made by extending a 2D shape along a third dimension. Some are made by rotating a shape around an axis, like the sphere we saw earlier in the video, for instance. One way to form a sphere is to rotate a 2D circle around one of its diameter lines. And another common 3D shape that can be formed by rotating a 2D shape around an axis is a cone. A cone can be formed by rotating a right triangle around one of its two perpendicular edges. Since the formulas for finding the volumes of spheres and cones are more complicated to explain, we don't have time to learn how we arrive at them in this video. So for now, it's best if you just memorize the formulas so you can use them on tests if you need to. To find the volume of a sphere, you use the formula volume equals 4/3 times pi times radius cubed. And to find the volume of a cone, you use the formula volume equals 1/3 times height times pi times radius squared. Let's try one example of each before we wrap up. Here's a sphere with a radius of 2 centimeters. Fortunately, that's the only dimension we need to find its volume. Our formula says that the volume of a sphere is equal to 4/3 times pi times radius cubed. Cubing the radius means multiplying it by itself 3 times. So we take 2 centimeters times 2 centimeters times 2 centimeters, which equals 8 centimeters cubed. Next, we'll multiply that by our approximation for pi. 3.14 times 8 is 25.12. And last, we multiply that by 4/3, which is the same as multiplying by 4, then dividing by 3, which gives us a volume of 33.49 centimeters cubed. Now let's try a cone. To use our formula to find the volume of a cone, we need to know 2 things. The radius of the circle that forms the base of the cone, and the height of the cone, which is similar to the height of a triangle. It's the distance from the point at the tip of the cone straight down to the center of the circular base. The radius of the base of this cone is 3 feet, and its height is 9 feet. So first, let's plug that radius into our equation and square it. 3 feet times 3 feet is 9 feet squared. Next, we multiply that by pi, again using 3.14, and we get 28.26 feet squared. You may notice that that's just the area of the base circle. But now we need to multiply that base area by 1/3 times the height of the cone. 1/3 times 9 feet is 3 feet. And 3 feet times 28.26 square feet gives us 84.78 cubic feet, which is the volume of the cone. All right, so now you know a lot about volume. You know that it's a 3-dimensional quantity of geometric objects, and you know that we measure volume with cubic units. You also learned how to calculate the volume of some basic 3D shapes. Of course, there's a lot of other 3D shapes that we didn't have time to cover in this video, but now you know about some of the most common ones. The key is to put what you've learned into practice by trying some exercise problems on your own. As always, thanks for watching Math Antics, and I'll see you next time. Learn more at mathantics.com.
Okay, we already know how to make a calculation of one prism. Okay, if you remember, okay, we have the formula, okay, of the volume, and that is equal to length times width times height. Okay, and if you remember, if I have a figure right here, okay, if I have a figure just right here, okay, and said in this part, my length, it's about 5 feet. Okay, this part is 3 feet. And this part, it's going to be 9 feet. Okay, the only thing I have to do is the multiplication. We know all of that. So we have volume, it's equal to, open parenthesis, 5 feet, 5 feet, okay, 5 feet times 3 feet, close parenthesis, multiply 9 feet. This is equal, okay, to 15 feet square. Multiply 9 feet. And this is equal, how much? This is equal to 135 feet cubic. Okay, this is all you have to do. Okay, this is all you have to do. But what about when you have to find the volume of 2 prisms? So let's watch a video again, another one. Okay, let's watch another video about Mr. J that will explain this.
Welcome to Math with Mr. J. In this video, I'm going to be covering how to calculate the volume of a composite rectangular prism. And if you take a look at your screen, you'll see 2 composite rectangular prisms, and we're going to find the volume of both of those in order to help you get this down. Now, you might remember, or maybe you forgot, and this is a quick refresher, but the formula for volume that we are going to use is length times width times height. And remember, volume is the amount of space a 3-dimensional object takes up. And as you can see, these aren't just plain old rectangular prisms. They're a little more complex. So it takes a couple extra steps, but the foundation of finding the volume is still going to be that formula. So let's jump right into number 1 here. And when we have composite rectangular prisms, the first thing we want to do is cut that figure into 2 separate rectangular prisms. So I'm going to draw a line here that's going to separate this into a left and right rectangular prism. I'm going to call the left-hand one A and the right-hand one B. Again, I cut the complex or composite figure into 2 rectangular prisms. Now what we're going to do is find the volume of A, the volume of B, and add those together. And that's going to give us the volume of the composite rectangular prism. So let's do A first. So I'm going to put our A and B, and then let's write out our formula for each. And once we get to this part, it's about picking out the correct lengths, widths, and heights for A and B. So again, let's do A first. So we need the length, and I consider the length how far back that rectangular prism goes. So we're going to want to see how far back, and that's going to be 4 inches. Times how wide is A? So A goes from there to there. So we're not going to use that 10 inches. That's a common mistake using incorrect measurements. That 10 inches goes all the way across. We just want right here. So we're going to have to look around this rectangular prism in order to find the correct number. And if you look up top, we have a 3 inches that matches with the width. So we're going to plug in that 3. And next is the height. And we could look here at this 4 inches for that. So we need to do 4 times 3 times 4 in order to calculate the volume of part A. 4 times 3 is 12, times 4 is 48, and these are cubic inches. Now, we're halfway done with the problem because that is the volume of just A. Now we need to do B. So the length, how far back? Well, 4 inches. Times the width, again, don't use that 10. That 10 goes all the way across. That includes A and B. We just want the width here, which is going to be 7 inches. And then the height, well, B isn't this full 4 inches that we use for A. It's a little bit shorter. So let's look back here, and this 2 inches is our height for B. So 4 times 7 is 28, times 2 is 56, and that's cubic inches. So now to wrap up the problem, I'm going to go to the top left of the screen where I have some room here. We need to do B, which is 56, plus A, 48, to get the total volume. And we get to 104 cubic inches. So our answer for number 1 is 104 cubic inches. All right, let's take a look at number 2. Oh, actually, before we move to number 2, I do want to mention something for number 1, and this actually applies to all of the composite rectangular prisms. There is more than one way to cut them or split them into 2 rectangular prisms. So for number 1, I have a left and a right. I could have, if you take a look where my letter A is, I could have cut it here so I had a top and a bottom rectangular prism. I would have gotten to the same answer of 104. So for number 2, I'm actually going to cut it so there is a top and a bottom rectangular prism. So I'm going to name the top A and the bottom B. Giving them a name helps stay organized throughout the problem. So we're going to set it up the same way as we did number 1. So let's put our formulas, and then it's just going to be a matter of picking out the correct dimensions. So for A, we need to take a look at length. How far back does A go? Well, the whole shape actually goes, the whole rectangular prism goes back 4 feet. So we're going to use this 4 for the length. A, how wide? Well, we could look up top here and see 2 feet. And then the height, we don't want to use this 8 over here. We don't want to use that 8 because that's the whole height of A and B. we just want A, which is going to be this 5 feet here. So we get to 4 times 2 is 8 times 5 is 40 cubic feet. Now for B, the length. Well, that whole rectangular prism or composite rectangular prism, all of it goes back 4 feet, which again, we use this 4 here. And then we need to multiply it by the width. Now B does go all the way across, so we can use this 7. Don't use this 5 here, that 5 won't be used. It doesn't go all the way across, so again, we need this 7. And then times the height of, don't use the 8, because again, the 8 is all the way up. It includes A and B. So we want right here, which is this 3 feet. You do not have to use all of the numbers when you get to these types of problems. So 4 times 7 is 28, and then 28 times 3 is 84 cubic feet. So we get to 40 plus 84, which is going to give us 124 cubic feet. So I'm going to write it inside of our composite rectangular prism here, because I'm running out of room. So 124 cubic feet. So there you have it. There's how to calculate the volume of composite rectangular prisms. Break your figure down into 2 rectangular prisms and then add those volumes together to get the volume of the entire figure. Hopefully that helped. Thanks so much for watching. Until next time, peace.
Okay, a very easy part of the topic. You only have to know how or which number have to use to get a calculation for the whole figure, okay? But if you see, it's very simple because we're going to use the same formula, okay? We're going to use the same formula. So, on the book, it's on the part number 10.4. Okay, so I'm on page number 605. Okay, I'm on page number 605. Please, everybody on the camera. Madeline, Catherine, Jose Valenzuela, on the camera.
What page?
I said page number 605. DM on the camera. I'm checking the list right now, people. So if you don't have the camera on, it's like you don't stay in classes. And I told you that. Ah, ya les había dicho, bandidos. Still missing this one. Who is the other one who's missing? Jose Manuel doesn't have the camera on. So people, okay. If you see in your book appear some figures, and we're going to work in the next hour for the figures, okay, with the calculations in the board, okay. I will use the board for the next class. So if you see, we have the same formulas, and we already know how to make the calculation for the 2 prisms, okay? Yeah, it's true. That exists in class. Wow. So, I don't know if you have any question about the topic. and about how to make the calculation with the two prisms. I know it's very, it's difficult in a way because you have to know which numbers you have to choose in the all the figure that appear in there. Yes, Diego Guardiola.
The easy part of that is know that we only have length, width, and width.
Yes, it's the easy part, but I will explain with the exercises I put on in the board. Okay. So I will explain that which number you have to choose to make the to make the calculation. So um, I don't know if you have another, Mister. How can we know what numbers we have to multiply in there a lot? Yes, that is the thing I tell you right now. I will tell you which numbers. I will tell you which number you have to take to start to make the multiplications. Okay. So I don't know if you have another question, people. No? Okay. So it's 8:56. I see you at 9:30. Okay? See you at 9:30 for the second hour of math. Please, no booking hands for the next hour. Bye-bye.
Bye.
Go and take a shower.